Section 3, Securing Your Cluster. In this video, we're going to be taking a look at an overview of Kubernetes role-based access control. There are several different areas that we're going to explore during this first video. First, we're going to take a look at an overview of the Kubernetes API access control layer. We're going to talk about how roles allow access at different levels. We're going to look into cluster and namespace scoping for roles, as well as coarse and fine-grained access tuning examples. For reference, you can see the link here to the Kubernetes documentation website that has a lot of information on authorization and authentication. There are four main areas of Kubernetes API access control. The first is transport. So that would be the use of SSL certificates and transport layer security to ensure that the connection between the human user or a pod service account is encrypted and protected. Next is authentication. That's the verification of the user or account accessing the system. This can be a user that's a member of a specific group that's been granted access, or a service account. Authorization, rules defining the account's permitted actions. And finally, admission control, modules that are built into Kubernetes that control access to resources. Related to authentication is authorization. Authorization takes the form at a high level of attributes and verbs. Attributes can include things like user, group, service account, or object type. Verbs would be specific actions that you can do with those object types. For example, you can use put, post, get, patch, and delete, which are HTTP verbs, or you can also use specialized verb categories such as pod security policy, RBAC, and authentication. RBAC is specifically the category that we're going to be interested in looking into. If you're ever unsure of whether or not the user you're logged in with has access to do something, in Kubernetes you can use the kubectl auth can command to check permissions. An example of this would be kubectl auth can get pods. And as you see here, there is more information specifically about authorization mechanisms in the Kubernetes documentation website. Let's talk a little about cluster and namespace scoping. So there is a bit of a hierarchy within a cluster that allows you to access either cluster level resources or specific namespace resources. You can take that from a cluster admin role, which gives you everything, all the way down to only allowing view on specific pods within a namespace. So you have the ability to have things at a very coarse grain or very fine grained, depending on the needs of your application. Cluster scoping allows you to access across all namespaces. Some object types that are associated with this are cluster roles and cluster role bindings. Namespace scoping allows you to access resources within a specific namespace. Typically, you will see more things like roles and role bindings that go into namespace scoping. An interesting point, cluster roles can be used with role bindings to scope access to objects in a namespace. For example, there is a cluster role that goes by the name of admin, which gives you administrative rights. And you can create a role binding to that cluster role that will grant a specific user, group, or service account administrative rights over a single namespace, as opposed to cluster admin, which would give you access to everything within the cluster. Let's take a look at some examples of scoping. First, we'll talk about creating a role binding that leverages a role for a user, group, or service account. You can see our user objects on the left, and on the right-hand side, there's a namespace, and within that namespace, you'll see a role binding that is associated with a role that grants access to a pod. The service account, group, or user would be incorporated into that role binding, which tells Kubernetes, allow this group, user, or service account access to this resource based on the role provided. You can also create a role binding that leverages a cluster role. Much like we mentioned just a moment ago, if you were to create a role binding within a namespace that points at a cluster role, such as admin, you can then take that and allow access to other objects within the namespace, such as replica sets or pods. Finally, you can create a cluster role binding that uses a cluster role for a user, group, or service account. So in this example, you can see the cluster level with a cluster role binding that is independent of namespace that allows the service account, group, or user access to a cluster role. Let's say in this case, it's cluster admin. Cluster admin will then tie to that cluster role binding and allow that user, group, or service account the ability to access all objects within any namespace, as well as specific cluster objects that are not bound to namespaces. It's important to take great caution when creating roles, cluster roles, role bindings, and cluster role bindings, because you can inadvertently give too much access to a specific user, group, or service account. Remember, it's very important to be explicit with your permissions.